So I don't know why these are the same, but I'm guessing that I messed up and recopied one of them twice. But I think the other one is maybe supposed to say, like, I can draw a complete graph, including finding the zeros, the x-intercepts, y-intercepts, and vertical asymptotes, okay? And then the other one is about the end behavior. So I think this first one is messed up. But I'm just going to keep going. All right. A rational function simply means it's the quotient, which is the answer to a division problem or the setup to a division problem, where the top is a polynomial function and the bottom is a polynomial function. Okay? The top can even be a constant, which is officially a polynomial function. All right. The domain, anytime we have an x in the denominator, what's happening with the domain? Two x plus 1 over x minus 3. The domain is all real numbers except 3. Whatever makes the denominator 0 is not part of the domain. All right. This is kind of the parent of all rational functions. This is just 1 over x, called the reciprocal function, and its asymptotes are the x-axis and the y-axis. The end behavior on this one is approaching a horizontal asymptote. It's approaching y equals x, y equals 0 is the horizontal. You've had to do that, right? You've had to write what is the end behavior doing on one of these on a quiz. You had to say it was approaching 0 on the far left and the far right. All right, this slide is crazy business, but what it's saying is you want to first factor and make sure there are no common factors to the numerator and denominator. If there are, if there is a common factor to the numerator and denominator, then there's going to be a hole in the graph most likely. Okay, there's an exception. We'll talk about it when we get to holes. So as long as there are no other common factors, then we're going to look at the degree of the numerator and the degree of the denominator to predict whether the equation has horizontal asymptote, slant asymptote, etc. All right, vertical asymptotes are any values that make the denominator 0. Okay. It says the real zeros of b of x, which is the denominator, and it's written x equals some number, and those are the numbers that make, oh, it says see next page. Okay. You write it as x equals, and it's the numbers that make the denominator 0. Then the end behavior asymptotes are either horizontal asymptote at y equals 0 if the function is bottom heavy. That would be like x over x plus 1 quantity squared. Everybody good? Why that's bottom heavy? Remember this stuff a little bit? If they're equal weight, like 2x squared over x squared minus 3x plus 1, this is equal weight. They're both degree 2. So they will have a horizontal asymptote at y equals leading coefficient over leading coefficient. Does that sound familiar? So this would approach y equals 2. This one was y equals 0. If it is top heavy, there's no horizontal asymptote. There could be a slant asymptote or an end behavior asymptote. So we're going to talk about that in a minute. Oh, maybe it's right here. No? Okay. If the degree of the numerator is 1 more than the denominator, then we're going to have to divide. And we're going to have to sometimes use long division, which is the whole purpose in learning this. In learning long division. Okay. X-intercepts. Any ideas? How do you know where it crosses the x? It's where the whole function equals 0. When can it equal 0? If the top is equal to 0, right? The bottom's equal to 0, it's undefined, yes? So as long as the top is equal to 0, that will be an x-intercept. All right? says occur at the real zeros of the numerator. Okay, the y-intercept is what happens when you put in x equals 0. It's possible for it not to have a y-intercept. If you get something like 2 over 0, when you put in a 0, then it doesn't have a y-intercept, right? Doesn't ever cross. All right. So here's examples. Degree what? On the top here, guys. Degree 1 over degree 2. So it is bottom heavy. And then it says it should approach y equals 0. This should kind of make sense. If we put an incredibly large number in, let's just say even 1,000, okay? We'd get 1,006 on the top, right? But we're dividing by 1,000 squared. So it doesn't matter how big the top is, the bottom is huger, right? So it's going to approach 0 because we're dividing by something much bigger than the top. All right, this says degree what over what? Degree 2 over degree 2. Okay, so that's called either equal weight, or I think the brown sheet calls it even Steven. Okay, so the idea here is that if I put in an incredibly large number, do you see that these two things are going to be the same, x squared and x squared? But when I take that incredibly large number that I've squared, this one I'm going to multiply by 2. So it's going to be twice as big as the bottom one. Now, if I'm putting in 1,000, 1,000 squared minus 9,000 is still a really big number, right? This doesn't matter much after you get incredibly huge. So this is going to all drop out and it's going to approach y equals 2, or leading coefficient over leading coefficient. Okay, this is bottom heavy, top heavy, just kidding, yes, degree 2 over degree 1, everybody okay? All right, this is new for most of you. In the past, you probably just said there is no horizontal asymptote. Now you have to find the end behavior equation, whether that is a slant asymptote or some other function. It can even be a parabola or something. Could I use synthetic division to divide this one? Okay, so this is one we could do by synthetic division. We would have to divide it. And it does say somewhere that when you divide, you get to ignore the remainder. It says here on this one, which you guys don't have yet, it says to find the end behavior or oblique asymptote when it is top heavy, you divide and ignore the remainder. All right. This is the one that you had when you took the pretest. All right. And I'm going to type something up that's a compromise of the two, I think. All right. So this is a pretty easy one. Can you look up here real quick? Tell me what the domain would be. All real numbers except... So I'd be okay with you just writing x cannot be 3. All right, find the equations of the vertical and horizontal asymptotes. Vertical asymptote is x equals what makes the denominator 0? 3. This confuses students. This says x can't be 3, and this says x equals 3. That's because a vertical asymptote is actually not part of the graph. It's a boundary, that's why we draw it as a dotted line. So these are not against each other. Do you understand that? By saying the domain can't include 3 and the fact that there's a boundary, this is just helping us graph it. All right, so x equals 3 is a dotted line that the graph will never touch. The horizontal asymptote, what is the degree of the numerator and denominator? Degree 1 over degree 1, so we do what? Even Steven or equal weight means y equals leading coefficient over leading coefficient. What's the leading coefficients here? So we get y equals 1. Both vertical and horizontal asymptotes must be equations. You can't just write 1. You have to write a line at y equals 1. Now, a horizontal asymptote is also not part of the graph. It is a boundary. It is a boundary that can be crossed. Vertical asymptotes, the graph will never cross or touch. Horizontal asymptotes, the graph will hug, but sometimes it will cross it and hug it from the other side than it did originally. It's weird. We'll see some like this, okay? This one, it does not. It does not cross. All right. I think that's one we just did. Ready to try this one, guys? Think you have this one on your practice? No? Yes? Somewhere? Is it already done for you? Where is it? Is it the bottom one? Okay, I was so confused. All right, first of all, when you type this in your calculator, super important that you put parentheses around the whole top and around the whole bottom, especially this time because they have factored the bottom. If we didn't put parentheses around the bottom, it would only divide by the x, and then it would multiply the whole thing by x minus 6 instead of dividing, order of operation. All right, so what can you tell me? It says determining asymptotes and intercepts. Well, what can the domain not be? X cannot be what, according to the denominator? 0 or 6. What does that mean about asymptotes? There are vertical asymptotes at x equals 0 and x equals 6. So this is counting by 2's. So there's x equals 6 and x equals 0. Any questions so far? All right. How about the 0? Are there any zeros or x-intercepts? What? Yes. What would make the numerator 0, right? Top equals 0 would be -2. So -2, 0, which this is counting by 2's, is a x-intercept. What about a y-intercept? Well, it's what you get when you put in 0, but does anybody see that it's not going to have a y-intercept? Because it already has an asymptote there, right? If we put in 0, we would get 2 over 0 times -6, which is 2 over 0, which is no y-intercept. Does that make sense if you didn't catch it along the way? All right. What's left in the directions? Just the graph? Oh, end behavior. We need to know about the, what's going on here? I don't really want to see, I do purple. We need to see what the end behavior is doing. It's degree what over what? Be careful. Degree 1 over 2, because this was x squared down here. And what does degree 1 over degree 2 mean? Okay, and if it's bottom heavy, what does it approach? Guys, think about it. If you have a little number over a really big number, it's going to approach 0. So the horizontal asymptote, it happens to have an asymptote, is at y equals 0. Now, guess what? We already have a dot on that line. Is that okay? Can it cross a horizontal asymptote? Remember what I said a minute ago? It will hug it, but it can cross it. All right. So if you plug it in your calculator in a standard window, anybody already do this? I think you get, trying to make it really big, but you get a picture like this and it's kind of hard to tell what's going on. Does anybody know what I did or how I did it to get this picture? I'm not sure I did change the window. I think what I did is I turned off the axes so I could see what the graph was doing. Does anybody know how to do that? It's under format. Is it second Second zoom, you could turn the axes off. It's under second window. Okay, so this is what I got when I turned off the axes so that I could see it a little bit better. Did you get this, or did I also change the window? Getting something like this? Don't remember if I changed the window. Not like this? Yeah. Go second, zoom, and go down to the one that says axes on or off. You're going to want to turn them back on, so remember how you got here, but you go back and turn them off. If you're having trouble graphing, make sure that all your little plots are turned off at the top. What was it, guys? X plus 2 divided by, am I doing it right? X times, what was the other one? Thank you. All right. Yep, that's not. So this is the standard window. Yeah, not so good. I might have tried a zoom decimal or a zoom square. Yep. I'm going to go back to zoom 6. Anybody getting anything any better? Anyway, this is the idea. I don't know what window I used to get it to look this nice. Well, changing it a little bit less to the left help, but is it actually perfectly horizontal right here, guys? No. Okay. If I turn the axes back on, anytime you have 2 vertical asymptotes, there should be 3 parts to the graph, just so you're aware. All right. If you want to look at the table, you could see some ordered pairs. I am definitely not going to be super worried about perfect points other than maybe the x and y intercept. All right. At -3, it's at -0.037. At -1, it's positive. Let's just go with it. Is it up here, guys? Is that what it did? I covered the picture up already. Okay, and it stayed really close down here. Did anybody find a point on this one? Anybody put in 2? Type a 2 on your graph for me. -1/2, so it's really close here. Just remember, it's counting by. And does it cross out here? If you put in a 10, is it crossing? I don't think it's going to cross that one because we didn't have another y-intercept. So I think that one stays above. You good? Any questions? Everybody got what they want off that slide? All right. Here's a little bit different one. The thing about this one is it's equal weight, but notice there are no zeros. Okay, neither one of these factor. So you end up with y equals 2 for the leading coefficient over leading coefficient. And in the middle here, it's doing some gobbledygook. Remember, we've seen a couple that look kind of like this. And if you put in a 0, you get 5. So it does cross the y-axis up here at 5. Just a different one you could get on a homework. All right. Do you have these two or not? No? All right. This one right here is equal weight. Where would it have a domain? Where would what could the domain not equal? X could not equal -5. It would have a vertical asymptote at -5. It is top heavy, so the horizontal asymptote would be where? Leading coefficient over leading coefficient? 15. Okay. If I set the top equal to 0, what will I get? If I set the top equal to 0, -3 over 15 or -1/5. If I put a 0 in, what do I get out? Yes? Okay. This is not the graph that goes with this one. It's the graph that goes with this one. All right. This has a top that factors x minus 3, x plus 2. Does that work? All right, so what can you tell me about this? Look up here, guys, because this is an example of a slant asymptote. All right, where's the domain? X cannot be -4. Vertical asymptote, therefore, at x equals -4. This should have said cannot. Okay. It is top heavy, so we would have to divide. Okay, can we do synthetic division on this problem? It's dividing by x plus 4. Is that okay? So we'd have a -4, and across the top we'd have 1, -1, -6. Bring down the 1, we get -4, -5, 20, and a remainder. Remember, we get to throw away the remainder? So what does this mean? Yes, it has a slant asymptote at y equals x minus 5. Okay, it's this one right here. Do you see what's going on? Does that look like it could be y equals x minus 5? All right, and over here was the vertical asymptote at -4, except I didn't draw it right. Should be over a little further. It shouldn't be crossing it. Try to slide it over, but somewhere in there. Okay, I'm going kind of quick because we have a lot of these to do. So you are going to want to find the domain, sketch asymptotes, plot x and y intercepts, and then it says plot at least one point in the test intervals determined by, so in between each of the asymptotes, plot at least one accurate point if you can. Now, sometimes that accurate point is 4,0.1, which is pretty hard to be accurate, but just graph it on the calculator and see what's going on. All right, the first quiz on this stuff, by the way, has no graphing, none. Okay, we're going to have a quiz on this stuff later this week, and it's just going to ask you, using the reference sheet, to tell me the vertical asymptotes, horizontal asymptotes, zeros, all that good stuff. You don't have to graph a single thing. Okay? And you don't get to use a calculator. Did I mention that? Because it's all about, can you factor and tell me where they are, and you don't have to graph it. You can use a scientific calculator. I'm okay with that. But all right. Find the domain of each function and the equations of the asymptotes. So, any domain restrictions here? Can x squared plus 1 ever equal 0? We get x squared equals -1. Do we have any real answers to that? Nope. So domain is all real numbers for this one. So therefore, does it have any vertical asymptotes? Nope. End behavior, which is the generic term for horizontal asymptote or slant asymptote or degree what over what? Degree 0 over 2, so it is bottom heavy, which means what? It approaches y equals 0. So it is a horizontal asymptote. Number 2, does the top factor? No. Okay. So the domain restriction is x cannot equal -1, which means there's a vertical asymptote at x equals -1. What about the end behavior? Equal weight? Everybody okay? Okay, so y equals leading coefficient over leading coefficient, or y equals 2. And that's a horizontal asymptote again. Does this have an x and y intercept? Well, if I put in a 0, what do I get out? 1 over 1, which is 1. How do I figure out when it equals 0? Set the top equal to 0, and I get what? -1/2? That's the kind of question that's on the quiz. Don't need a calculator. All right, what about this guy? Domain, x cannot equal -1 or 2, so there are vertical asymptotes at both x equals -1 and x equals 2. Degree? Degree 1 over 2, so it is bottom heavy, and it has a horizontal asymptote then at y equals 0. Okay, what about x and y intercepts? If I put a 0 into the whole thing, I'd get what? 3 over 1 times -2, which is 3 over -2, so -3/2. How do I make the whole thing equal 0? Set the top equal to 0, so I'd get -3, 0. Everybody okay? Any questions? All right, so this is one that has a weird end behavior. Do you see that it's top heavy? And so we have to actually divide. Could we use synthetic division? Yes, because the numerator is an x minus c factor, so we'd have 1, -7, 10, bring down the 1, multiply, add, we get to throw away the remainder, so the end behavior is y equals x minus 4. Does that match with the picture? It look like that could be the equation, y equals x minus 4 right through there. All right, when you have 2 vertical asymptotes on a graph, it means there are 3 parts to the graph. It has to be doing something in between and on either side of those. Sometimes this in-between piece is very hard to find. It can be way down off the bottom of your graph or way up off the top. So use your table if you need to figure out where a reasonable value in between there is, and then change your window. All right. Oblique asymptotes aren't always lines at all. That's why it says they're not only called oblique asymptotes, they're also just called end behavior asymptotes. I don't know if you can see this one over here. Can you see this? It says x cubed is being divided by x minus 1. Can I use synthetic division for that? I can, right? It would be 1x cubed, 0x squared, 0x, and 0. Bring down the 1, multiply, add, multiply, add, multiply, add. What's this mean? The end behavior is approaching y equals x squared plus 1x plus 1. It looks like a parabola. if I type this in my calculator, x cubed over x minus 1, and I push zoom out a couple times, it will just look like a parabola. I don't know if I put that in here. Can you do it real fast? Type x cubed divided by parenthesis x minus 1. Start with a standard window. And it looks kind of weird, right? Can you see that? I should have the light off. But if I zoom out, zoom, and then hit 3, I think you have to hit enter. Does it start to look just like a parabola? Okay, there's just some weirdness going on in there at 1 because it had a vertical asymptote there. All right. Do you have this example? Thank you. You have this one? 2x cubed over x squared plus x minus 12? No? All right, let me run through it real quick. If you factored and you wanted to graph it, look what I did here, guys. Do you see how many parentheses you got to have? Well, I put the top in parentheses, which you could probably get away without. But the denominator, if you're going to put it in factored form, you still need an extra set of parentheses around the top. I mean around the whole thing on the bottom. Everybody okay? This is what, I just want to show you this. This is what the original Zoom looked like. Is that the whole graph? How do I know that's not the whole graph? Doesn't it have 2 vertical asymptotes where? -4 and 3. -4 and 3. What did we just discuss? There's got to be something going on either side of those, yes? Okay, so then I did a zoom out and I got something like this. Okay, does that make more sense? To find the end behavior, I'd have to divide. Uh-oh, because it's top heavy? What would I have to do? Yeah, 2x cubed divided by x squared plus x minus 12. We're just not going to do that one right now. Here, look, they did it for us. And it became, after they threw the remainder away, 2x minus 2. Does it look like, oh, here they have a 1 down here, but does it, okay, just kidding. Does it look like it approaches y equals 2x minus 2 out on the far ends? Do you see? Thanks. All right, now we're finally getting to holes. We don't have much time left. All right, a hole in the graph is when a numerator and denominator have a common factor. Okay? The thing is that you didn't have to do in Algebra 2 possibly is you have to find the actual ordered pair where the hole is this time. Okay? So what you have to do is figure out where the hole, what value of x the hole is at, common factor is at, and then after you reduce it off, then you're going to plug that value back in to find where the hole is. Okay? There is an exception to there being a hole. If the equation was this, everybody looking? If I reduce this, there's still one in the denominator, right? That actually makes a vertical asymptote, not a hole. But most of the time, we're not going to have that. So it's going to look like this. After we factor, and then this would mean there's a hole at x equals 5. Everybody okay? And then what you're going to have to do is cancel that off and find the y value at the hole by plugging 5 in here, which would give me what? 8 over 7? So that would be the hole. All So it says, I like how it says it on the brown sheet. It says, canceled factors are wholes. Set the canceled factor equal to 0 and solve for x, and then plug that value back into the beautiful new simplified equation to find the y value of the whole, okay? Math teacher obviously wrote that one. All right, do you have this example? Okay, so this factors x plus 2, x minus 2. If you're not good at factoring, this is the lesson that it's going to kill you. Denominator, how does it factor? X and x, factors of 8 that make negative 2, minus 4 and plus 2, okay? So the first thing you always look for is the common factor. That's why on your tan sheet, wholes are at the top of the list, okay? Does this have a common factor? Yes. The domain, x cannot equal negative 2 or 4, okay? But after we've said that, we can now cancel this because there's a whole where? Be careful. You set the canceled factor equal to 0, so you get negative 2. Then you put negative 2 back in. What will I get? Isaac, you with us? Negative 2 minus 2 is negative 4. Negative 2 minus 4 is, so the whole is at negative 2 comma 2/3. Okay, what about vertical asymptotes for this question? You said the domain can't be negative 2. That was a whole, but what's the other one? Right here, x equals 4 is a vertical asymptote. And the end behavior on this one would approach what? Y equals, anybody go back to here? Leading coefficient over leading coefficient? 1? Because it's not bottom heavy? Even after we divide it out, its leading coefficient is 1 over 1. Everybody okay? All right. So let's see if we can get through one more example. Oh, this is a hot mess. I want to skip that one. Let's do this, number 5. Do you have this number 5? Okay, how does the top factor? Okay, the denominator has x plus 1. All right, tell me the domain. All real numbers except negative 1, okay? Which means there is a vertical asymptote at x equals negative 1, dotted line, x equals negative 1. Okay. What do we do next? According to your sheet, because there was no whole, go down the brown sheet. Horizontal or end behavior. It is degree 2 over degree 1, so we have to do what? It's top heavy, we have to divide. So we can do synthetic division. There is a remainder, but we get to just throw it away. What is this equation? Y equals x. Yep. There is a slant asymptote at y equals x. We got that by dividing. So that line here would just look like this. All right. What if we put a 0 in? Top and bottom we get. Okay. So 1, 2, 3, 4, 5, 6 down here is where it would cross. And if we set the top equal to 0, where is it crossing the x-axis? Negative 3, 0, and 2, 0. It has an x-intercept at 2 and at negative 3. All right, this is the picture you get on your calculator. So it's doing this. And this. All right, on your assignment sheet, guys. Guys. It says goes with worksheet 9AB. It has 7 things for you to start doing, okay? We'll do some more examples tomorrow, and we'll have work time because I'm going to add worksheet 10 to this. So you can get started on worksheet 10 if you don't want to do bookwork tonight, okay?